All around us, there's this invisible AI making decisions that shape our daily lives. I'm talking about everything from the price of our rideshare to how efficient our power grid is. So let's pull back the curtain and take a look at the powerful technology that's working behind the scenes.
Okay, think about the last time you used an app like Grab. 1 minute, the price is one thing, you wait a few seconds, and it's something totally different. How in the world does it figure out the perfect price for that exact moment? It feels a little like magic, right? Well, it's actually a really brilliant form of artificial intelligence.
So let's actually dig into that. Let's pull back the curtain on that price you see on your screen. What is going on behind the scenes?
The secret, it turns out, is a super powerful type of machine learning called reinforcement learning, or RL for short. This is basically the brain that's constantly at work trying to balance supply and demand to get you a ride as quickly and efficiently as possible.
But how does it learn to do that? Well, the core idea is surprisingly simple and actually very human. It learns by doing. It learns through trial and error.
At its heart, reinforcement learning is all about an AI agent learning to make the best decisions, all on its own. The best way to think about it is like teaching a dog a new trick. When it does something right, you give it a treat. That's a reward. When it does something wrong, maybe you give it a firm no. That's a penalty. Over time, the dog figures out the behavior that gets it the most treats. RL works the exact same way. And it all happens in this constant cycle we call a learning loop. First, the AI takes an action, like setting a price. Then, the environment, the real world with all its traffic and weather and people, reacts to that action. The AI then gets a reward or a penalty based on that outcome. And finally, it uses that feedback to update its strategy for the next time around. It does this millions of times, getting just a little bit smarter with every single loop.
So let's bring this right back to our Grab example. Let's say the AI sets a price, and that leads to a rider getting picked up super quickly. That's a fantastic outcome. The system gives the AI a reward, a little digital treat. But if the price is maybe too low and a driver cancels the trip, well, that's a bad outcome. The AI gets a penalty. Through all this constant feedback, it learns to find that sweet spot, the optimal pricing that keeps both riders and drivers happy.
Now, here's where it gets really fascinating. Dynamic pricing in a ride-hailing app, that's just the tip of the iceberg. This exact same learning method is being used to solve some of the most complex problems in the entire world. I mean, just look at the range of things this can tackle. In gaming, it's not just playing the game. It's developing entirely new, literally superhuman strategies. For robotics, it's solving the incredibly difficult challenge of physical movement. And for really complex systems like logistics or energy grids, it's finding efficiencies that humans just can't see on their own.
Take the ancient game of Go. The AI AlphaGo used reinforcement learning to play against itself millions and millions of times. The result? Well, it produces, and I'm quoting here, superhuman performance without human-designed heuristics. Now, heuristics is just a fancy word for human shortcuts or rules of thumb. AlphaGo wasn't given any of those. Instead, it discovered these bizarre, totally counterintuitive moves that top human players thought were huge mistakes, right up until they led to a win. It literally rewrote the strategy book for a 3,000-year-old game. And it's not just about abstract thinking, right? It's about physical action. For a robot, something that seems simple to us, like grabbing an object it's never seen before or walking on uneven ground, is an incredibly complex physics problem. So instead of programming every single possible movement, RL lets the robot learn on its own through trial and error. It literally develops a feel for the physical world.
This incredible power also applies to massive, critical systems like our energy grids. When you use RL to manage the flow of electricity, you see huge gains in efficiency and much lower costs compared to the old way of doing it with manual planning. It can adapt in real time to sudden spikes in demand or changes in supply from solar or wind, optimizing a complex web that's just too big for humans to manage at that speed and scale.
So when you put all of this together, you start to realize that reinforcement learning isn't just another algorithm. It's a fundamental shift in how we solve really, really hard problems. So what's the big takeaway here? Why does RL matter so much? Ultimately, it's because it thrives in complexity. It's built for problems that have many steps and really long-term goals. And its greatest strength is adapting on the fly to environments that are constantly changing, whether that's rush hour traffic, a spike in energy demand, or a new move in a game. It is designed to find the absolute best way to optimize an entire system for whatever goal you give it, whether that's max revenue or max efficiency. And that brings us to a really fascinating final thought.
We've seen this kind of AI master unbelievably complex games and optimize the logistics for an entire city. So, what's next? What's the next grand challenge in science, in medicine, in society that we should point this incredibly powerful decision making AI towards? Something to think about.